Okay, another related rate question. Here we have a ladder 10 feet long races against the vertical wall, and it says if the bottom of the ladder slides away from the wall at a rate of 1 feet per second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet away from the wall? Well, you know the deal. I will draw two pictures for you guys. First, this is the floor, and let's say this is my wall. And I will also draw the following. It says the ladder is 10 feet long, right? And during the whole process, the ladder is not going to be longer nor shorter. So I will just draw the ladder to be like this. Let's say this is 10. Okay, and it's always going to be 10 during the whole process. Therefore, I can just label the 10 right here, right away. And I will just show you guys what happens right here. Well, it says the bottom of the ladder is sliding away. So that means you are pulling this away, right? So you can imagine this is being pulled away and this is going to sliding down. Therefore, the next picture is going to look like this. This and that's supposed to be 10 and 10, alright? So just excuse my picture. Anyway, this is still 10. This is how we are going to do it. We have to label the things that are changing. We know that this distance and this distance, they are changing. This is the vertical distance. I will just label this as y. This is the horizontal distance. I will just label that to be x. And once again, during the process, you can see that this is gotten shorter and this has gotten longer. And we care about at the instant that it says the ladder is 6 feet away from the wall. This part, 6 feet away, so that means x is equal to 6. And now let's go back to the equation and pick up the things that we have. It says the bottom of the ladder slides away from the wall at a rate of 1 feet per second. The bottom, that's the x that we have right here, right? This right here tells us we have d what? dx. Good. dx dt equals to 1, right? And the question is asking us how fast is the top of the ladder sliding down. So let me just write this down right here. How fast? How fast is also asking for the rate. And in our labeling, we want to know dy dt. Okay? So that's pretty much the information. And now let's look back to this picture and come up with an equation that relates to x, y, and 10. Well, this is nicely enough to be a right triangle, so of course we can use the Pythagorean theorem. Namely, this square plus that square is equal to this square. So I'll write down x squared plus y squared equals to 10 squared. And pay attention to this. I put down 10 squared right away because I know this length is always 10. So I can just put down the 10 squared right away. I am not going to plug in 6 right here yet. Alright? This is later on when we have the rate equation already and then we're trying to solve for the dy dt. This is later on because this is given the instant. But in terms of the equation that we have, you can plug in any constant right away. And then of course, if they are changing, you keep them as variables. And now we can totally differentiate this now with respect to t. First, the derivative of x squared with respect to t is just 2x and dx dt. Next, we add it with the derivative of this is 2y and dy dt. Good. And what's the derivative of 10 squared? The answer to this is not 20. The answer to this is just 0 because this is just the derivative of 100. It's a constant 0, right? So that's pretty much it. And for the people who really want to just label this as like z squared, you realize you get 2z dz dt, but dz dt stays the same, so that's 0, right? dz dt is 0 because z stays the same. Anyway, this is it. Now you see that let's just plug in numbers. 2 is 2. And now I can divide everything by 2, but I'm not going to do that. It doesn't really matter. x is 6, so let's plug in 6 right here. And the x dt is given to be 1. And notice I label this as positive 1 because x is getting longer, right? X is getting longer. So this is positive 1 for dx dt. And then we add it with 2 is still 2. Y is, well, this is a quantity. When the instant that x is equal to 6, we actually need to find out what y is. And to do so, in fact, I have to rely on this equation for the quantity. So when x is 6, I plug into here. Let me figure this out. We have 6 squared, that's equal to, 6 squared plus y squared, that's equal to 10 squared. And then this is 36 plus y squared is equal to 100. And then minus 36 on both sides. Y squared is equal to 64. Take the positive square root, you just get y equals to 8, right? So y is equal to 8 when the moment that you have x equals to 6. And then with that, you can solve for dy dt. That's really nice. Let me keep this on the left hand side. Well, 2 times 8 is 16, so let me put on 16 dy dt. Bring this to the other side, that's going to be negative 12, and then divide both sides by 16. So let me just do that right here for you guys. Divide both sides by 16. The good old algebra days, right? Just cancel things out nicely and cute. Huh? Anyway, dy dt is equal to, you reduce this fraction, and you get negative 3 over 4. Right, that's pretty much it. But now we have to interpret our answer carefully. Dy dt is negative because this distance is getting smaller and smaller, right? Because it's sliding down. So y is getting smaller and smaller. That's why we have a negative rate. And depends on how you want to answer it. In my class, you can just label dy dt is equal to negative 3 over 4 and attach the unit, which is feet per second. This right here is okay. Or if you want to answer this properly, you just write it down in sentence. And you have to use the phrase sliding down, right? You can just say the top of the letter is sliding down at a rate of, and if you use the phrase sliding down, this includes a negative already, so you just say sliding down at the rate of positive 3 over 4. This right here should be a positive 3 over 4 feet per second, right? So depends on how you want to answer it. That's pretty much it.